So I wanted to give us a better introduction into binary because I feel like I didn't really explain it as well as I could have. I gave some basic concepts, and I think I explained logic gates decently well, but binary and why it's useful, I feel like I could have done better. So let's start right over here with just how do we even read this? What does this mean? Well, the way that we represent binary digits in Minecraft is just using this lamp, which can either be off or on, with off being a 0 and on being a 1. Now, usually when digits are next to each other, like they are here, and if they have the same block underneath them, that is me trying to say that they are part of one number. Okay? Because we can have multi-digit numbers, as we can in, anything else. But how do we read that? How do we read, for example, that? What does that mean? How do we know how to decode that from binary into a readable form that we can understand? Well, it's actually very simple. The first digit we multiply by 1. Next digit multiply by 2. Then by 4, and then by 8. So, in this example of 1001, we would do, that would be this, okay? And you see, okay, so we have this is on times 8 is 8, and this is on times 1 is 1, so 9, which is correct. 1001 is 9 in binary. Now, fun fact, in case you want to expand this beyond just 4 bits, what these numbers really are, these 8s, 4s, 2s, and 1s, the astute among you may notice that this is just 2 to the 0, and then 2 to the 1, 2 to the 2, and so with this being 2 to the 3, this would just be 2 to the 4, multiplied by 2 to the 4. Now, you might be wondering, why does this really matter? Like, it's kind of cool a little bit, maybe, but how does this really help us with making computers? I think most people understand that binary is the language of computers, but I don't think a lot of people understand why. It's because binary is so fundamental. It's so simple that we can utilize it with logic gates. And using the combination of logic gates and binary, we can do things like this. This is called a half adder, which we take in 2 bits of information, separate. Hold on, I'll make sure you can see that they're separate. These are not from the same digit. These are 2 separate numbers, okay? So we could do, for example, 1 plus 1 and get an output of 2. We just did math with nothing but logic. Now, this is a fairly simple system. If you want a tutorial, then say in the comments. I will gladly make one. But you can kind of see that this isn't very big. And if you look at it carefully, you might even recognize a few things. Like this, right here, is just our XOR gate from earlier. Earlier as in a different video. But utilizing this logic and utilizing binary, we can do these amazing things like adding. We just did 0 plus 1 equals 1. That doesn't seem interesting, okay, because it's adding 1-digit numbers, but we can make much bigger and much more interesting things which can do much more for us. So that is kind of the general purpose behind binary and why we utilize it. And again, if you would like me to make a tutorial on the half adder, I will, but also expect a full adder coming with more explanations about binary very soon, because full adders are much more interesting than half adders. Though I'll probably make one because it's good to know about. But yeah, thank you very much for watching, and expect more soon. Bye.